Okay, today we're looking at balancing equations. So I have a basic equation set up here. Now, when you're balancing equations, what you want to do is make both sides of the equation, so the reactant side and the product side, have equal amounts of elements. So to start here, you're going to look at Fe. So Fe, there's one on this side, there's one on this side. So the Fe is good. Next, you'll want to look at the H, because that's next in order. So H, there's one here, there's two on this side. So keep that in mind. So there's one here and two here. Now looking at this side, the Cl. One Cl here, and two Cl on this side. So now that we've determined that there is one Fe here, one H here, one Cl here, one Fe here, two Cl here, and two H here. So now we'll want to balance all of these chemicals. So first we'll do the Cl. So there's two Cl here, one Cl here. Put a 2 in front of the HCl. Now on this side you have two H's. So let's check the other side to make sure that the two H's are balanced. So as we know, there's H2 on this side. This is your fully balanced equation. But check, after you're done balancing, always check. So we have one Fe, two H's, two H's, two Cl's, two Cl's. Okay, that one is done. Next equation, we have Ca Br2 plus H2SO4 goes to HBr plus CaSO4. Okay, so we're going to do the same thing here. Start at the left side. So 1 Ca, 1 Ca. We know that the calciums are good. 2 Br, only 1 Br on this side. Okay, so we know for later that that needs to be balanced. Now here, 2 H's, 1 H on this side. Now we've got 1 SO4, 1 SO4. Side note, for chemicals such as SO4, or sorry, not chemicals, for ions such as SO4, PO4, NO3, anything that looks like this, hydroxide, 8OH, you're going to want to look at them as wholes. So don't look at them as a O and an H. Look at it as a hydroxide. Same with the NO3. Don't look at it as an N and 3 O's. Look at it as an NO3. So here we have 1 SO4, 1 SO4. Alright, so let's start off with the BRs. So we put a 2 here. That also solves our H problem. So now we've got, check your answer once you're done. So 1 Ca, 1 Ca, 2 Brs, 2 Brs, 2 H's, 2 H's, 1 SO4, 1 SO4. Okay, now we're going to do a bit of a harder example. We've got CaOH2. So now when you're writing out an equation such as this, CaOH2, a molecule, sorry. So the Ca has a charge of 2 plus, OH has a charge of minus 1. So when they cross, this looks like CaO 2 H's, but it's really CaOH2. So you want to put a bracket around the OH. So now you know that this 2 goes into the H and it goes into the O. Okay, so now we've got CaOH2 plus H3PO4 because PO4 has a charge of -3 and hydrogen only has a charge of +1. Alright, this goes to Ca3PO4 brackets around the PO4 2 plus H2O. So there's just a water on the end there. Alright, now let's do counting. 1 Ca here, 3 Cas on this side. 2 OHs here. Okay, so once you have an instance like this, where you have an OH on one side and an H2O on the other side, it's helpful to write your H2O. You can just cross it out and write it as HOH. So now you've got a hydroxide here. But it's still an H2O molecule, it's just written differently. So this will also help when we're trying to balance our hydrogens on this side. So we've got, yes, 3 Cas, 2 OHs here, 1 OH here, 3 hydrogens on this side, 1 hydrogen on this side, 1 PO4 on this side, 2 PO4s on this side. So when you're balancing reactions, it's all about trial and error. So you're going to be writing them down and writing your coefficients, erasing them a bunch of times. So for this one, we'll start off and go to the right. So 3 Cas. We've got 3 Cas here, 3 Cas here. Now we've got 6 hydroxides because the 3 multiplied times the 2, that leaves us with 6 OHs. So we can write a 6 here. And now we've got H+. Now we can just write a 2 here, because 2 times the 3, that's 6. So now we've also got 2 PO4s. So now that we're done, check your answer. 3 Cas, 6 OHs, 3 times 2 is 6. 6 OHs. 6 H's, 2 times 3, 6. 6 H's. 2 PO4s. And 2 PO4s. So now we've got one more example here. FeCl2 plus Na3PO4 goes to Fe3PO4 2 plus NaCl. Alright. So we've got 1 iron, 3 irons, 2 chlorines, 1 chlorine, 3 sodium, 1 sodium, 1 PO4, 2 PO4s. Now this question is a bit trickier than the previous ones. I'm going to just move this plus sign over. Okay. So let's start off with the Fe. So we need 3. There we go. We got 3. That would give us 6 chlorines. 3 times 2, 6. So we'd have to put a 6 in front of the NaCl. So now that gives us 6 chlorines, 6 sodiums. So now we can put a 2 here, and there you go. So now we've got 3 iron, 6 chlorine, 6 chlorine, 6 sodium, 6 sodium, 2 PO4, 2 PO4. Thank you.